Good evening, everybody. Thank you so much for joining us on this first day of reInvent, at least for some of us. We have a packed session today. I'm going to walk you through Kinesis video streams, talk to you about what it means to ingest data from media pipelines, store it, process it, and walk you through a demo of building such a pipeline end-to-end. And even more excitingly, I have with me today Amit Vaswani, who's the head of infrastructure services for Amazon Go, a close customer and partner of Kinesis video streams, who will walk you through how Amazon Go's Just Walkout technology is built using Kinesis video streams, among other services. So before we dive into the details today, how many of you have actually had a chance to play with Kinesis video in any shape or form? Show of hands. Not too many. How many of you have video analytics-based applications that you've either already built or are thinking about building in your organizations today? A lot more. That's exciting and encouraging. And hopefully, today you will go back with some thoughts, some knowledge, and perhaps a little bit of inspiration on how you can get about on that journey. And if you've already built amazing stuff, I would love for you to come back and tell me about it so that I can learn from you. So we're going to get an overview of Kinesis video streams. We're going to look at target use cases. We're going to spend some time understanding what it means to have producer software, as we call it, or a set of software assets that have to build and run on media pipelines to grab the frames and then send them over to the AWS endpoint. We will learn more about the video processing analytics ecosystem that is built around Kinesis video streams, and I'll do a little bit of a demo. And then Amit will come on stage to talk about his and his team's experience with Kinesis video before I come back and take some questions about the service. We're all here today because clearly we feel that video is now an important part of how we're thinking about advancing our business. Many devices out there, devices that are embedded in our home appliances, devices that are present at the intersection of street corners on cities, devices, camera-based devices that are part of manufacturing and automation systems. And what's common in increasingly a number of these devices is the mind-boggling number of sensors that are on it. And one of the preeminent sensors that we're seeing is the image sensor. Connected devices plus image sensor ends up creating this massive opportunity to do something meaningful with this video data outside of simply playing back and watching it. However, as we went down in this journey, we learned a few things, that building a video ingestion system is kind of hard. Why is it hard? It's hard because it's fundamentally a multidisciplinary problem. What do I mean by that? The journey of video data typically starts with the device. And embedded devices are not the easiest things to program. There is a bewildering array of hardware, firmware, software combinations that have to be, those challenges have to be surmounted so that you can write the right kind of lower level software that can reliably connect into the media pipeline and stream into the cloud. Once you're able to figure all that stuff out, you actually have to build a reliable, scalable, elastic cloud service that can accept these video streams, do so securely, and be able to vend those streams to your applications for downstream processing. And of course, you have to do all of this in an operationally excellent manner. So can it be done by yourself? Absolutely, and I'm sure some of you have done the same. But is it easy? Is it pain-free today? It's not. And that ultimately became the motivation for Kinesis video streams, just by way of context. Some of you may have heard of the Amazon Kinesis data family of products, Kinesis Data Streams or Firehose. And Kinesis video streams intends to solve the same qualitative problems, but to do so for audio, video, and related time encode metadata. So really what we want to help is have customers be able to securely connect and stream from many devices, be able to focus on building their own vision-enabled applications, not have to worry about how to build playback of video be it live or on demand, and to be able to do so in a fully managed, secure, reliable form. Some of you may already have meaningfully interesting use cases in your head or things that you're trying to prototype today. But some of the things that we're seeing now as customers adopt Kinesis video streams, and some of your use cases might map to these, include the following. There's a whole bunch of use cases that are emerging around the home, broadly speaking. I would argue that possibly 50% upwards of us have some sort of home security camera already in our homes. And that's where the brain immediately goes through. But there are so many other home appliances or devices that are now getting imbued with image sensors that makes it easy to now build a whole bunch of different use cases. This is an example of a pet monitor. And as we will learn later this week, not only are there things to monitor pets, but pets, robotic pets that can monitor you that are built with Kinesis video streams. Another big use case is broadly in the public sector smart city domain, where you've got a number of cameras on city intersections as part of critical national infrastructure, as part of trying to harness understanding of how traffic flows operate. And the same cameras are now fundamental to be able to drive for emergency first responder kind of scenarios. And we see customers building machine learning applications that can take the input video streams and then do things like license plate recognition on those streams using some of our ML services. And then, of course, there's a whole greenfield set of opportunities that are broadly being created in the manufacturing automation space, where just like industrial sensors enable customers to understand what is happening in their infrastructure, they can now do the same by using machine vision. Let's now transition to do a quick product overview. There are 4 things to kind of bear in mind when you think about the Kinesis Video Streams product. Life starts with number 1, a producer SDK, a software asset that enables you to capture the media created on the device and then securely and reliably send it to an AWS resource called a video stream. And now this stream is responsible for the durable capture, reliable capture and durable storage of the media and making it available for applications. And the applications can be of the real-time variety. This is where obviously low latency is important, where you value frame-by-frame analytics. Or these applications could be ad hoc batch driven, which means that latency may not be the most important criteria, but you still want access to fragments, some or all the fragments contained in the stream for any kind of analytics. The 4th construct is your application. This is where a lot of the interesting stuff is going to happen. This could be a license plate recognition application. This could be a pet detector application. This could be an application that allows you to do remote control of a drone or of a vehicle that is elsewhere. But that is where your responsibility as developers lies to go build that interesting thing, of course, with the help of a variety of other AWS services. So let's look at some of the details around the Kinesis Video Producer. Now, a lot of you, when you start building with Kinesis Video, this is the first asset that you'll be looking at. Important to clarify that this is different than the AWS SDK assets. And the reason is that this SDK on the Kinesis Video side is more than syntactic sugar and best practices usage of the Kinesis Video APIs. It certainly does those things. But what's important to understand about this SDK is that it integrates with the underlying media pipeline. At a very high level, when you take out your phone, you've got an image sensor in it, and I'm simplifying this. You have an image sensor, you've got some sort of an encoding chip, H.264, H.265 being common modules, and at the core level, that constitutes a media pipeline, the output of which is encoded bit frames. And that's where the journey starts, and that's where the Kinesis Video SDK enables you to capture, package, and reliably and securely stream those video frames and fragments into the cloud. Of course, it by default wraps in all of the best practices for authentication, authorization, and provides you ways to do things such as insert metadata about what the camera device itself is seeing or detecting as part of the fragment itself. And these are all capabilities that are built into the Kinesis Video Producer SDK. And the way it's been built is it live starts in the platform independent layer, part of the core C code. It is a bunch of SO files. Outside of core camera manufacturers or embedded systems engineers, it is unlikely that you will use that. It is more likely that as developers, you will start your journey on the object-oriented layer, where the entire API set is duly wrapped up in both C++ and Java forms. And we've created that across a whole host of different operating systems. We've also produced Docker images of that for those of you who are looking to kick the tires pretty quickly and get started. Of course, at AWS, the thing that we enjoy and love the most is building fully managed APIs that just work. And no different with Kinesis video streams. We've got a set of control plane APIs and a set of data plane APIs. As you can see, just like many other services, there are a whole host of create, describe, delete kind of APIs. But something that is interesting in Kinesis Video that I want to call out is the get data endpoint. Now, this is an API call that is called by either the producer, so the thing that is sending the data, or by a consuming application to request and gain access to the actual stream. And this enables this kind of decoupling, if you will, between the producers and the consumers and allows them to rendezvous on the same stream. And this is something unique and different. Thankfully, this API, and it's built into the producer SDK. So you don't explicitly have to program for the get data endpoint. But for those of you who end up writing raw software from scratch, that's something to bear in mind. All streams have the ability to retain data indefinitely. And you, as developers, can choose to dial up or dial down the retention at any point in time. And so the only interesting API that I'd want to call out on this slide is the update data retention API. So if you have a super interesting stream that is monitoring a critical part of your physical layout, you may want for that stream to have 30 days retention. On the other hand, you may have some streams that are pointed at portions of your physical site that are not that interesting. And you may say, hey, maybe I need a week's worth of retention, and that's it. And the cool thing is you can always change this data retention at any point during the operation of the stream. So after the control plane APIs, let's now look at some of the data plane APIs. 4 core data plane APIs to bear in mind. The most interesting API, in a way, is the pair of put media and get media APIs. Now, all of you are very used to a RESTful API model that AWS presents. But the put media and the get media APIs are streaming APIs, which means that they operate in a manner wherein once the producer grabs an endpoint and starts submitting video frames and fragments to it, it doesn't tear down the connection after a given fragment is sent out. That connection is kept open, and a series of frames and fragments are put through on that open connection. On the flip side, a consuming application on get media is then able to retrieve the underlying frames and fragments in close to real time. And so this streaming nature of the APIs makes the video streaming experience closer to what you and I know of it as consumers of a variety of other video streaming systems. And so this put media, get media experience, again, is something that is captured in the SDKs and is qualitatively different than a typical RESTful API interaction with most AWS services. We also have a Playback API. One of the things that customers kept asking us for after the initial launch of Kinesis video streams was the ability not to actually analyze the video data, but simply be able to play back the media that was being submitted by the security camera, by the drone, by a robot, and to be able to just watch that video. And they wanted to watch that video somewhat close to real time. They definitely wanted the ability to go play back that video on an on-demand basis. And so middle of this year, we launched the default capability for the HTTP live streaming, or HLS standard. And all of that experience of building and managing infrastructure that takes in raw media streams and trans-packages them and then replays that data, more accurately plays back that data in browsers, in app conditions, is now enabled through the get HLS streaming session URL operation. This is arguably the easiest way for you to play back the media that is ingested into your stream on majority of browsers, majority of application, mobile operating system platforms. Okay, so now that we've talked about the act of ingesting media using the producer SDK, and we've talked about how the core API sets operate at a high level, I'm going to now talk about the other half of Kinesis video streams, which is now the ability to actually analyze your video. In the last year or so, there's been this massive explosion in the kinds of machine learning applications that can do interesting, meaningful things with all kinds of data. And video and image data are no different. When we launched with default integration with Amazon Rekognition Video, which is a fully managed service that enables developers to simply call APIs such as APIs that can do things like detect faces. And when you upload a known collection of faces, it could go ahead and even identify those for you based on that privately uploaded collection. In the last month or so, we've also introduced an integration with Amazon SageMaker. Amazon SageMaker is a fully managed service to build, deploy, and train machine learning models at scale. So now you can bring your own models and have the entire system operate in an end-to-end fashion. Outside of these fully managed services, we have a variety of software that developers can use to build into their own custom applications and deploy on their own AWS infrastructure for analytics. And the key here is that a variety of use cases, real-time analytics, non-real-time batch-oriented processing, playback of media on demand, or playback of media in near real time, are all kinds of applications that can be supported concurrently and parallelly through Kinesis video streams. So you could have one stream coming in, one real-time video analytics application, one HLS playback application. You could have another machine learning application that is simply using the data to train its model. And you could have all of these different applications operating off the same stream without you having to build and operate different solution architecture components. As part of the processing ecosystem, we have an open source Java-based library called the Kinesis Video Streams Parcel library. This library is intended for developers who want to now start building their own applications. And it starts by enabling them to do things like extracting frame-level objects or fragment-level objects that constitute the data inside of a video stream. It'll enable them to extract any metadata that has been attached to the fragment that was originally sent by the producing device or the camera. It'll enable them to do things like strip out all the metadata and then merge the fragments to generate, if you will, a clip of some variety. Among other things, it can also it can decode the incoming raw frames and then decode them to JPEG, PNG, or a variety of other image formats, which may then be required for any downstream processing analytics application. And of course, the way the library is built is that you could then factor that into your application and have that scale to thousands and thousands of concurrent streams of video. About 10 days ago, we announced the latest integration of Kinesis video streams, and this is with Amazon SageMaker. The way the template works is called Kinesis Video Streams Inference Template, KIT for short. KIT gives developers the ability to sample, parse, and decode the incoming media frames and then reliably invoke a SageMaker endpoint that contains the model that you own and run. As the model generates inferences, it then pumps that into a Kinesis data stream from where those inference results that are tagged with every single fragment number are now available for any business logic to then consume and process. So the actual kit comprises of the library that I talked about previously, and it also contains a fully managed CloudFormation template that spins up resources like Fargate Compute, which actually runs the core compute for analyzing the video itself. It includes the ability to spin up DynamoDB, which manages the checkpoints and leases as the fleet elastically grows or shrinks in response to the incoming video. It integrates with the SageMaker endpoint to reliably call the SageMaker endpoint for any number of inferences that were created, for any number of decodes that have happened, and it then pumps that video data, pumps the inference data back into a Kinesis data stream. And all of that is fully managed. And in a demo, I'm going to show you how this thing will work live. However, rolling out your own machine learning application is obviously not the only way to go about it. And we feel fortunate that a variety of video analytics partners have integrations with Kinesis video streams. And what that means for enterprises and companies who do not wish to make their own investments into machine learning is that they can now use some of these partners and say, here are my cameras that are hooked up to Kinesis video streams, and here's how I wish to, and I would like for it to be analyzed using your software, machine learning driven software capabilities. As with several AWS services, Kinesis video streams is a purely pay-as-you-go model. So remember, you're not spinning up any instances, you're not managing load balancers, you're not managing storage systems, and you're not managing any APIs to pull them all together. The abstraction you see is a stream. The stream ingests data. That's the data ingested per gigabyte. The data is consumed, and consumption can fall in one of two buckets. You could be consuming the data for your analytics applications. That's the data consumed per gigabyte. Or you could be consuming the media data for HLS playback, and that's the data consumed using HLS. And finally, because storage retention is an optional factor, when you decide to store media, there is a data stored per gigabyte month pricing dimension around that. And all of this is fully pay-as-you-go. If your streams are not sending, if your cameras are not sending any data, you don't pay correspondingly. So you could have 1 million devices connected, and maybe only 0.1% of them stream at any point in time. And that's the only scenario under which you actually actively end up paying for those resources. So I'm going to transition now and do something brave. Wonderful. So what I have here is a $19.89 Logitech webcam that I ordered off Amazon. And what I'm going to do now is fire up a producer SDK instance that's going to be running on my demo laptop. This is USB connected into my machine. And so what you should see is the producer SDK connecting in, pulling in the frames from this Logitech device, camera device, sending it over to the Kinesis video streams endpoint, where we should hopefully see the media play. So you should see the actual video playback. And then I have the background infrastructure for analytics with SageMaker spun up already. And so I will take you through some of the moving parts over there to kind of demonstrate how increasingly easy it is now to build together these kinds of media pipelines. So here goes. So this is my Kinesis video streams management console. I have created just one stream here for you. And I'm going to fire up my SDK. So that's, remember, is running on my laptop. Looks like it is, we're in business. OK, so it's streaming. It should probably see me at this stage. So what I'm going to do is navigate over to my management console. And my stream is called Windows Stream that I'm going to now click on, which should bring up the management console, which has a video viewer built into it. And you can see that with some delay, you can totally see my face. Right? OK. And I'm also going to hover it over this bottle to see if it picks up stuff. All right. OK. So far, what we've established is we are doing some variety of streaming pretty easily from a random device into the cloud. OK. So now we go over to the Lambda logs, which are sitting on the other side of the Kinesis data stream that is now returning results from the actual inference model. And what you'll see here is that you should see objects such as person. You'll see object, which is a cup. Now, that is purely the nature of the model itself and how trained or not trained it is. But the key point here is that now you have Lambda that is pulling off the inferences results that have been already published into the Kinesis data stream that are giving you those results. And this is happening close to real time. So it continues to detect, I guess, me. So all of this stuff is now a matter of a few clicks, and all the core object code, the actual source code behind this is available for any developer to pick and choose and run. As part of the kit, you also have the ability to act on a variety of different metrics. So everything from frame level metrics to saying how many frames are actually decoded, latencies, end-to-end latencies from when we ingested to when it was actually processed. Here you can see we've got about a 200 millisecond latency for the pipeline to go end-to-end. A variety of other metrics around how the actual ECS service is being utilized, the CPU and memory utilization, how many records have been published into the Kinesis data stream, and things like how many times SageMaker, where the model actually runs, was invoked, as well as the corresponding Lambda invocation. So you, as a developer, as an operator, have the ability to now see this end-to-end as part of your infrastructure. So hopefully that was interesting to see how all these different moving parts, which until recently still required a tremendous amount of energy to put together, have now become fundamentally easy for a majority of developers to go and tackle. With that, I'm going to now announce on stage Amit. Amit Vaswani is the head of infrastructure services at Amazon Go, and he's going to talk to you about his team's journey with streaming video and specifically with Amazon Go. Amit?
Thanks, Adi. Good evening, everyone. Hope you are all enjoying the first day here at reInvent. My name is Amit Vaswani, and I'm the head of infrastructure services for Amazon Go. Today, I'll be talking about Amazon Go and our use of Kinesis video. It's late on I know it's late on a Monday evening, so I'm going to try to make this as lively and entertaining as possible. And with having said that, let's start off with a quick video that introduces Amazon Go.
4 years ago, we started to wonder, what would shopping look like if you could walk into a store, grab what you want, and just go? What if we could weave the most advanced machine learning, computer vision, and AI into the very fabric of a store so you never have to wait in line? No lines, no checkouts, no registers. Welcome to Amazon Go. Use the Amazon Go app to enter. Then put away your phone and start shopping. It's really that simple. Take whatever you like. Anything you pick up is automatically added to your virtual cart. If you change your mind about that cupcake, just put it back. Our technology will update your virtual cart automatically. So, how does it work? We used computer vision, deep learning algorithms, and sensor fusion, much like you'd find in self-driving cars. We call it Just Walk Out technology. Once you've got everything you want, you can just go. When you leave, our Just Walk Out technology adds up your virtual cart and charges your Amazon account. Your receipt is sent straight to the app, and you can keep going. Amazon Go. No lines, no checkout. No, seriously.
So we built Amazon Go because we believe that fundamentally, nobody actually likes to go to a store and wait in a line. People don't go to a store to wait in a line. They go to a store to shop. Over the years, there have been several innovations in brick-and-mortar retail stores, all the way from credit card machines to barcode scanners to self-checkout stations, and so on. But the fundamental process of shopping in a store has remained largely the same. You enter the store, you go take the products you want, you wait in line for checkout, you pay, and then you leave. With Amazon Go, we're trying to change that experience. You enter the store using our app, you go pick the products you want, and then you leave. There are no lines, no checkout, you just walk out. So how do we do it? Well, all we needed to know was which Amazon accounts are shopping in the store and what products they picked so that we could accurately charge customers when they were done with their shopping trip. That sounds simple enough. What makes that complicated? Well, life would actually be pretty simple if this is what we had to deal with. Having one or a few people in the store walking around leisurely, picking one product at a time, preferably a big product like that, and walking out of the store. That doesn't seem too hard. However, reality is more like that. Reality is stores that are crowded. Reality is people who are shopping in close proximity with each other. Reality is kids running around the store, babies going in and out of strollers. Reality is that people don't shop one item at a time. Reality is natural shopping behavior where somebody picks a product, looks at it, puts it back in the shelf, sometimes puts it back in a different shelf. Sometimes they're shopping as part of a group, so they hand it to a friend or to a relative who eventually puts it in a different shelf where somebody else comes along and picks the product. Reality is products that are identical don't always look the same. And conversely, products that look the same aren't always identical. For example, plain yogurt and vanilla yogurt. It's really hard to differentiate between those two. So to solve this, we, as in the Amazon Go team, decided to use computer vision as our core algorithm. We built our own cameras, and we really pushed the state-of-the-art forward in deep algorithms to be able to accurately answer the question of who took what. We built techniques to fuse together signals from cameras and other types of sensors. We built vision algorithms that are capable of understanding natural shopping behaviors, as we talked about previously. And we built a host of other services that are required or necessary to be able to operate a group of sensors and to be able to run a production store with high availability and high accuracy. One such set of services that we built is our streaming services. For our algorithms to be able to accurately understand customers' shopping actions, we need to capture the moment of truth when a customer picks an item or returns it back on the shelf. So we built a set of services that are responsible for capturing the video frames from the cameras and passing it on to our algorithms running in downstream services. These streaming services have to be extremely reliable. They have to operate with high throughput. They have to be resilient to host failures. They have to be resilient to network blips. And they have to operate with extremely tight bounds on end-to-end latency between when the action is triggered and when our algorithms are able to process it. And that leads me to how our team began our partnership with Adi and the Kinesis video team. We launched our first Amazon Go store back in 2016. And when we launched our first store, we were using our own set of streaming services that we had built ourselves. At the same time, AWS was building the Kinesis video streaming product for AWS customers. So it seemed like the perfect opportunity for collaboration. Since then, over the last 2 years, we've closely partnered with the Kinesis video team, initially to influence product direction, and subsequently to onboard as their early adopters. So why did we do this? What's in it for us, the Amazon Go team? Why did we decide to onboard onto Kinesis video? First and foremost, using Kinesis video allows us to focus on our unique values. By freeing ourselves from the undifferentiated heavy lifting of having to move video frames through the network, we can instead focus on tackling unique challenges in computer vision and machine learning and other in-store customer experiences. Secondly, using Kinesis video streams lowers our operational cost. As Adi mentioned, our costs become elastic. We only pay for the video streams that we use rather than paying for any fixed infrastructure. It obviously helps us launch faster. It improves our time to market. This year, we've launched about 5 additional stores. And being able to use a managed service for video streaming rather than building our own infrastructure for every store is definitely a simplifier for us. And finally, it helps us lower our operational burden. This one's pretty evident. Just like nobody likes waiting in lines, nobody likes their pagers going off either, hopefully. And using a managed service certainly reduces the likelihood of incurring operational burden in running stores. For the Kinesis video team, partnering with Amazon Go gave them an early adopter. We were able to validate their production use cases using a real-world application. And being an early adopter, we were able to push for production scale and tier 1 availability from the very get-go. Points of friction and how did we overcome them? So any deep integration at this level is bound to run into some issues, and we certainly had our fair share of those. Your use cases might be different, but I wanted to share some of these that may or may not be relevant to those who are considering adopting Kinesis video streams. As I mentioned already, we were early adopters of this product. And as early adopters, we had to make some fairly significant modifications to the Kinesis Producer SDK to meet our needs. Depending on your use case, you may or may not be able to use it right out of the box. Secondly, we found that Kinesis video streams works really well for streaming data continuously, as Adi had mentioned. However, we had some use cases where we needed to do RESTful APIs. We had use cases for non-streaming put APIs. And for those use cases, we had to work with the Kinesis video team to be able to support it in our application. Similarly, we found that Kinesis video streams works really well, and it's very durable. It works really well for durable video streaming through the network. However, we have some use cases where our our bounds on end-to-end latency were extremely tight. We needed the latency between the video frame generation and consumption to be extremely small. And for those use cases, we continue to use our own video streaming services at this point. And finally, just like all other AWS services, Kinesis Videos has its own set of service limits. And it's important to understand that some of these limits are easily configurable or can be changed by filing a service request, such as how many streams you're using. However, there's a certain set of hard limits that are inherent to the architecture of the service. For example, the TPS on certain APIs. And it's important to understand those and incorporate those in the design and architecture of your own service. Well, that's it for me. I would like to hand it off to Adi at this point. I'm excited about continuing our partnership with the Kinesis video streams as we continue to focus on building more delightful features for our customers. Thank you.
Thanks, Amit. So we have some time to take questions. There are 2 mics out here, so if you feel you have some questions you want to share, please do so. The other thing is Amit will not be taking direct questions about Amazon Go. So if your questions are around Kinesis video streams, use cases, producer SDKs, consumption applications, I'm very, very happy to talk through those here. So any questions? You've got one here on the right. Yes, sir.
Yeah. Why did you choose SageMaker over now? I see you got video recognition.
Oh, so the question is, why did we choose SageMaker over recognition video? And we did not. Customers can use recognition video to take advantage of the built-in integration. Just like that, there is yet another service that you can use, which is SageMaker. You can use both of them in tandem. Secondly, there are a whole bunch of other use cases that may not fall into the narrow video recognition context. You might be wanting to analyze audio. You might be wanting to analyze radar signatures, so on and so forth, for which you may want to build your own custom models and run them in SageMaker.
Do you know if video recognition is only video, or can it also take in audio?
So very specifically, the integration recognition video has with Kinesis video streams is for video only. Another question there?
Hey, oh, that's loud. My question's about latency. So what's sort of the best, or I guess the lowest latency that you can expect? And the use case that I was thinking of is, for example, remote gaming, where you have some game running in some server instance and you want to send that video stream to a consumer device. And for that, you'd probably want to low it, or at the highest 200 milliseconds, depending on what game you have. So are there any architectural changes or anything, or is this even a recommended service for that kind of a use case?
A great question. So the question is around latency, specifically for a use case around, I'm going to say, remote viewing of a game being played online. Forgive me for the simplification. What I would say is that when you want to target clearly sub 1 second latencies end-to-end, you should not use HLS. HLS is a fragment-oriented standard, and the specification itself requires, there is a certain amount, the architecture requires it to be a certain way. If you're going to be building, if your requirements are around that, then you should build your own player. So renderer, surface flinger, and playback controls using our Get Media API directly. So the Get Media API is a real-time API. Originally, it is built for analytics. So it doesn't do the kind of trans-packaging, for example, or encoding required typically for viewing applications, because that's not the design point for it. However, such an application can be built by someone who is adept at building players. If you do that, you're now looking at a world where you can attain those sub 500 millisecond latencies, but then you are on the hook for building your own player.
All right, thanks.
Yeah, welcome. You have a question there?
Sure. My question is kind of along the same lines in terms of from ingestion to encoding to consumption, what's time behind live if we use Kinesis video streams?
Yeah, so just to be kind of clear with the terminology, this question is also around end-to-end latencies. There are two distinct paths to bear in mind. There is the put media to get media path, where the frames are being put on the wire as they're generated, and then they're presented on the get media interface, API interface, for any application to consume. Now, on that path, our P50 latencies are much less than 1 second, right? And that is indeed why you can see that in the demo with SageMaker, all those steps could happen, Kinesis video streams, the Fargate instance, sampling, decoding, invoking SageMaker, and the stuff comes by, and you would still be in the few hundred millis. When you look at get the HLS API, there you are going to be paying, the rule of thumb is you'll pick a fragment length, typically let's say 1 second long, which is what you would pick on the camera producer device. This is what the encoder says. I'm going to give you a fragment and assemble it of 1 second. It's going to compose of 25 frames inside of it. When you use that, all things considered, you can use a rule of thumb of between 2x to 2.5x of the fragment length for the video to actually be rendered on some sort of a player. So that's what you're looking at on the get HLS API. So two different data paths from a consumption perspective, two different latency profiles, two different use cases, really.
And just a quick follow-up in terms of if we kind of take the same problem but scale it to 100,000 concurrent users or more than that, what will be the impact?
So the question is around what happens when you have 100,000 concurrent users, to which the question I'll have back for you is that at that point, you're going to have to use a CDN. I'm guessing that this is still for viewing live media.
Correct.
And if you're going to use a CDN in the mix, you're going to be adding a few more single-digit seconds of latency to get it consumed end-to-end. But when you build a solution architecture that includes a CDN like CloudFront, our belief is that the number of users themselves are not going to impact the latency itself. But you will pay a certain amount of latency. You will incur more latency on account of the solution architecture and composing it with something like CloudFront for distribution.
Thank you.
Yeah, welcome. Question there, please.
Yeah. So quick question. Are we able to use WebRTC as a producer?
So the question is very simple. WebRTC is a producer, and the answer is no, no. However, if you wouldn't mind talking to our product manager, Girish, who's right here, please. He would be very interested in understanding your use cases as we evaluate how else do we evolve the Kinesis Video Streams product roadmap. What's your use case?
We'd like to use commodity hardware for some
I'm sorry, what's
some
that?
analysis. We would like to use commodity hardware like Chromebooks and things like that for some analysis.
I see. Commodity hardware like Chromebooks. Got it. Thank you.
And second question is, I've seen you guys are using Fargate in order to process like the inference.
Yeah.
Any reason why you chose Fargate over maybe a Lambda or something?
Really good question. So we are looking to release the underlying software fully into the community. You could use, in theory, for ECS any compute type. It is ECS based more than anything else, and Fargate was the compute type that we picked. So number one. Number two, why not Lambda? Is because if you recall, in my presentation I talked about put media and get media being streaming APIs, where we hold the connection open as we are consuming the underlying frames and fragments. And that streaming API support has not been built yet with Lambda. The second thing is that these are long-running applications, right? You can imagine that a video stream is being pumped continuously for several hours at a time, and typically we want for the compute infrastructure that supports it to also be live for the duration of the stream. So those two factors right now mean that we haven't been able to cobble together the support with Lambda, but I suspect that those things will change as Lambda accommodates for more and more use cases, and we plumb the support through.
Okay, thank you.
Thank you. Thank you for your question. Yes.
Hi. Yeah, I'm curious as to whether a stream can process 3D depth data, like from a point cloud. The classic example being, I guess, the Microsoft Kinect, or recently, I think Intel's brought something out very...
Yeah. So this is a good question. This is about, if you will, more exotic data types, like point cloud data. So the core Kinesis video format, if you will, because underlying all of this, the data is being packaged in a format of some variety. It's based on Matroska. So it's, for those of you in the know, it's the .mkv file, which incidentally is the more foundational construct behind WebM, which is the foundational construct behind things like what you use for YouTube video viewing. The reason I'm giving that theory is that we openly specify what it is that the format looks like. You can actually send any kind of data inside of a Kinesis video stream at the end of the day. And only when it comes to actually viewing the video, playing it back, do we require things like H.264 encoded data, such with at least, with the fragment being such that there is at least one iframe in that fragment. Those concepts only really get enforced when you want to play back the media either in our console or using the HLS capability itself. But you could happily send any kind of data on put media, package it, we'll just package a default and present that on the get media API where your application can have at it. We, from a Kinesis video streams perspective, would happily do that, and we would have, without throwing up any problems. So that's kind of the good news. The bad news is that there isn't anything specific to make the task of point cloud processing any simpler, though. Yeah. So can a use case use it? Yep. Is there anything special, though? No.
Awesome. Thanks.
Yeah, you're welcome.
Hi. Glad to know about the inference template you have introduced.
Yeah.
Is it possible to tag the frames in the video stream and then process it at the Lambda?
So instead of fragment, so just to kind of make sure that I understand the question is, can you tag the frames instead of the fragments themselves? So the way that the integration, the kit integration with SageMaker works is that as the video frames that comprise, so a fragment comprises of multiple frames, the software is going to decode every single frame in that fragment. And it's going to, there is additional functionality there where you can choose a sampling frequency. So if you don't want to sample every 25 frames per fragment per second, you may wish to change that. But right now, as it stands, is that it will sample and decode every single frame. And then it passes on that decoded frame as some sort of image format, JPEG, PNG, so on and so forth, to the SageMaker endpoint, which contains your model. So the inference that is being returned by SageMaker is actually for the frame. The thing is that the frame is part of a fragment, right? And that fragment will have the fragment ID or fragment number associated with it. So the actual inference is happening on a per frame basis today. Does that answer your question?
No, if we could infer on the device in the camera itself and then tag the frame.
Oh, sorry. So the question was really around metadata inferencing on the edge device itself. You're right. So today it does operate at the fragment level, but as I said earlier, you could kind of work around the fragment tagging and insert additional metadata that gives hints as to what frame ID it actually belongs to. So there is a way to kind of work around that, and I'd be happy to kind of chat in more detail offline once we're done here on how we could do that. Okay, thank you. Any other questions? One more?
Hi. When you're making a producer and I want to make my own producer and I just have a series of frames, do I have to then encode them in the MKV format before I send them off?
No, thankfully you don't. If you use the producer SDK, it takes care of the packaging capability. As long as your device is sending H.264 encoded frames, which in our experience, vast majority of devices in today's world do, you're good to go.
Okay. Also about like when you were demoing it and you have a poor Wi-Fi connection, is it able to elegantly reduce the quality of the video, or if you lose connection completely, will it elegantly get it back, even because you're using a streaming API?
Got it, got it. So really great questions around, broadly speaking, the resilience of the producer SDK software in the event of misbehaving connections, which happens a lot. So the first question was around, would it dynamically change the quality, maybe reduce frame rate, or reduce resolution, as the case might be. So the producer SDK in that regard behaves quite simply. Because it is not an encoder, it is not going to try and drop frame rates or mess with resolution. If the encoder hardware itself decides that it needs to do that, the producer SDK kind of behaves in simple ways. Think of it as a pipeline, the image sensor, the encoder, and then the producer SDK software, and it's just going to happily package and send what the encoder decides to provide it. On the second aspect, which is around what happens in the face of network connection drops, if you will, we have the concept of a content store and a content buffer that is built into the SDK. So content can be locally spooled on the device, subject to whatever memory constraints you have in there. And then once network resumes, it will try and purge that. Of course, you can decide to drop the data if you care more about recent data, or you could decide to send it back. There are some rough edges, in all honesty, around how much of a buffer you can maintain on the device, how reliably it can then respool all of that data, because you'll be in this mode where, let's say you've been out for several minutes and the device has generated a whole bunch of data. You still want to send the live data while backfilling this older data. So that part of the experience isn't fully, cleanly implemented yet, but that's something, again, that we're actively exploring.
Thank you.
Thank you for your question. It's really good. Yes, ma'am.
Going back to the Amazon Go implementation, you mentioned that there were use cases for a RESTful interface. Can you explain and elaborate a little bit more on what those were and how that related to your user experience on something that should be hypothetically instantaneous?
I'm not sure, unfortunately, that I'm able to answer that question around Amazon Go's use case in depth here today. I apologize. Any other questions? One more?
Adi, one quick question. It's a very high-level question. How does DeepLens fit into this?
Oh, lovely question. DeepLens is a producer. The simplest way to think about it is AWS DeepLens is a producer. Today, there is a KVS, Kinesis Video Streams module, that you can simply put into DeepLens and start streaming into Kinesis Video Streams. Actually, that has existed for since early summer. So that exists. The more interesting things start happening when you want to integrate DeepLens's capability to obviously do the detections on the device, which is what it is built to do, and how you integrate that with something like our metadata per fragment feature. Right? Now, we get excited about things like that because you can imagine a world where your SageMaker does the detection, whatever that you've trained it to do, and then as the fragments are being sent into Kinesis Video, you tag it with that detection. Now that metadata and key value tags, key value pairs, and the fragment, which is the actual video, travel together. And what you could do is then access the tags on the cloud side to build your own, let's say, search infrastructure. You have all the fragments that are stored and indexed based on time. And now you have this index that you can build that contains all the detections that have been made. And now suddenly you have the foundations for a very rich index to recall and replay data from. That sort of stuff that's super exciting. But it works today. The producer stuff is super simple, exists as a module that you can use today. Thank you. So we've got just about a minute. Are there any other questions? Wonderful. Thank you so much for all of your time and attention. I really appreciate it. Thanks.